Okay. Hello, everybody. I think we're all back, or almost back. Welcome to this week's Learning Space, everyone. I am your host, Nicole Gallucci. I am not through the wall between Georgia today, as you can see.
One wall today, and a lot of space.
Down the road. Yes. We're right next to each other in internet space, so welcome. Georgia, my co-host here.
Hello.
And
oh, I see a dog behind you. Wait, sorry.
Yeah, that's Macy. She's lazy.
In the dark. Okay.
So yeah, she's not a co-host. She's background. But she's pretty quiet, so I could trust her to hang out there for the hour. So thank you and welcome, and thank you for joining us. I know this is an unusual time for us. Some of you guys are used to watching us over dinner, but if you don't get to catch the live broadcast, of course, you can watch after the fact. And there's Nancy in the Q&A. So hi, Nancy. Nancy Graziano is checking in from New Jersey.
Almost missed it.
Hi. I know. So we have an awesome show today. This is a topic I've been wanting to do for a while, and it kept slipping my mind, and I had to try and figure out who the right people were. And then I got this email from one of my friends who we were grad students together at University of Virginia, and she sent this along about the SDSS Voyages program and this cool educational opportunity. So we're going to get to that in just a second. I do want to remind you guys that during the Hangout-a-thon a couple weeks ago, I did say if we reached our funding goal for the hour, I would get an astronomically themed tattoo, and I would poll our regular Learning Space viewers for ideas and suggestions. So I've set up a very simple Google form for that. I will post that on the event page, in the comments, so I'll post that there in the event page comments. So go to the event page for this show or the YouTube link. It'll show up in the comments there. Go to the Google Forms and check out that link. The suggestions we've already gotten, because you guys know me so well: the Atacama Large Millimeter Array, the VLA and D configuration, very specific, Richard, Cassiopeia, the constellation of Cassiopeia, and of course a flocculent galaxy. So continue to send in your requests. We'll do a poll at some point in the next couple of weeks, and I will go ahead and get my next astronomically themed tattoo crowdsourced from you guys. So I'm keeping up my end of the bargain from the Hangout-a-thon. So that'll be fun. It's an excuse for me to get another tattoo, another astronomy tattoo that I wanted. So
I'm glad you're taking it well and kind of already had a little something like that in mind.
Yeah, I did. I just never got around to it. And I've been telling we had some guests on a while back. The Mad Art Lab crew might get their help in designing it, since they're actual artists who love science. So we'll do that. Well, I'll rope some of them in as well to help me with the design. All right. Excellent. So let's introduce our guests here. We have Karen Masters and Kate Meredith. So hello, you guys.
Hello.
Thank you for joining us, especially since you had just had a group meeting some number of hours ago and we're a bit tired.
Good fun with international collaborations.
Yes, yes. Time zones are fun. So actually, Karen, I think it was an email from you that had gone out to a lot of the people in the SDSS collaboration about Voyages, and so my friends in that collaboration forwarded along to our outreach group, and I got a little excited and asked you guys if you wanted to participate. So thank you for coming on the show. And why don't we get each of you to introduce yourselves, and then Karen, maybe you can talk a little bit about what is SDSS in general. That sound good?
Okay, sure. That sounds great. So I'm Karen Masters, as Nicole said. The reason I'm sitting here today is that I have a position with the Sloan Digital Sky Survey. I'm the Director of Education and Public Outreach for the Sloan Digital Sky Survey. So that's one of my hats. My main hat is I'm an astronomer. I'm an academic. I work here at the University of Portsmouth in a department that's called the Institute of Cosmology and Gravitation. And my research tends to be about disk galaxy evolution and about how you can use morphologies of galaxies as a clue to understand their evolution and how they fit into the universe. And one of the projects that I've been really heavily involved in throughout the last 6-7 years that relates to that is Galaxy Zoo. So I'm the project scientist, so I'm behind the science team for Galaxy Zoo. So hopefully, if any of you have contributed to that, thank you very much. I've used that in my research.
Yes, we definitely have lots of citizen scientists who are happy to mark galaxies, because galaxies are awesome. Classify galaxies.
So those are the main hats I have, and that's why I'm here today. So Kate.
Hi, I'm Kate Meredith, and I'm assuming you can hear me. I was having trouble with figuring out where the mute button was.
We can hear you. 2 thumbs up. 2 entire thumbs up.
Great. Yeah, I'm all thumbs today. So I am a teacher by profession. I started off in natural resource management and environmental science, and I have worked in LA County and rural Wisconsin, and ended up in teaching in my hometown after graduate school, and just ended up in astronomy because somebody needed me to teach an astronomy class, and one thing led to another, and I have stayed in astronomy since then, and that's when I decided I wanted to stay home and raise kids. I did this part-time because it's still really handy to say, you know, I'm working on quasars while you're staying home with your kids. So after a few years, I have worked for University of Chicago at Yerkes Observatory, long distance kind of commute, mostly working from home, and I've worked for the Sloan Digital Sky Survey doing education and public outreach, little projects here and there since about 2004. And so I did use Sloan data with my students, and have, you know, just sort of made it my personal passion as to how to get authentic research into the hands of students on a timely basis so that the research is actually current without killing the teacher. So that's been what has driven a lot of what I've done over these past 10 years. And so when we looked at, with the next generation science standards coming out, we looked at, you know, what are we going to do with the materials that had been developed in, you know, 2000, 2003 on Sky Server. You know, how are we going to update them? We decided to start doing a full rewrite, and that's where I have been playing for the last few years, and that's me.
So you wanted me to introduce the Sloan Digital Sky Survey a little bit?
Yeah, for people who are new to that.
Yeah, so so the Sloan Digital Sky Survey has been, it's an astronomical collaboration, and it's something that's been running for more than 15 years now. It's often called the largest astronomical collaboration. The way it's funded, it's not like a national program or anything. Different universities contribute funds to be part of the collaboration. And in the late 90s, that's a royal we, because I was not involved at the time. The Sloan Digital Sky Survey built a telescope at Apache Point Observatory. So there's a 2.5-meter telescope there, and you guys have a picture of it that I sent to you. I don't know if you can share it now or put it later. But this telescope has now imaged over 30% of the sky. So it's imaged almost all of the sky it can see. Right, it's in the northern hemisphere. It's in Arizona. There's a picture of the telescope. Yes, there it is. The telescope. And so it can't see. Obviously, can't see 100% of the sky, but it's imaged a lot of the sky it can see. That imaging, all the original images that we put into Galaxy Zoo were from the Sloan imaging. But more than that, once the camera was taken off the telescope, and it's now in the Smithsonian, it's in the basement of the Smithsonian because it's an artifact of historical importance, the camera of the Sloan Digital Sky Survey, it became a spectroscopic telescope. So it takes spectra of astronomical objects. It splits the light up into this very detailed rainbow, and we measure the spectral lines emitted or absorbed by the astronomical objects. So it measured redshifts, which can give you distances to 1 million galaxies, and the spectral part of the Sloan Digital Sky Survey is ongoing, and we continue to run. So right now, I just got the observing report from Sloan. I think they've got a little bit of data last night from the telescope. The weather hasn't been brilliant this spring. But we're taking spectra of galaxies, both nearby galaxies in a program called MANGA, which is mapping nearby galaxies. So taking many spectra right across the galaxies. There's also spectra of very distant galaxies being taken, and spectra of stars in our own galaxy in a part of the surveys that's called apogee. So it's very much a live, active survey, ongoing astronomical observations, but also with this 15-year history and an incredible sort of scientific legacy of making this data publicly accessible via a variety of interfaces. So once the proprietary period is over, so it's usually a year after the observations have been taken, Sloan releases this data publicly for anyone to use, including for educational purposes, and that's where Kate comes in. So probably a good moment to end that introduction.
And actually, at this point, I believe the stats are that 20% of the papers written in scientific journals right now cite Sloan data. And
that wouldn't surprise me at all. In all of the reviews I've seen of the scientific productivity of different observatories, the Sloan Digital Sky Survey telescope, it's just off the charts. So, and that includes telescopes like Hubble, which are amazingly scientifically productive, but Sloan just really is a big hitter. And largely, in my view, because of this policy of making the data open and making it a resource for scientists around the world to use.
Yeah, yeah. This was something that, I mean, if you're at a small university, if you're in high school, you can access this data and get to working with real data. Like I said, only a year after it's been taken, which is quite soon. And they've worked really hard to make it easily accessible in various formats as well.
Yeah, it's possible there's too many ways to access the data, or maybe not. Sloan, we like different ways of accessing the data, but yeah, there's a lot of effort gone into making the databases both very powerful. You can really use them for very powerful, very in-depth scientific analysis, but also as easy to use as possible.
Yeah, and if you take a look, there's a couple of screenshots that I sent you. 3 and 4 show. The Sky Server database has tools on it. One of them is the Navigate tool, and there's the Navigate tool, and that allows you to visually pan around the database. So you can choose a particular location by the RA index over on the left-hand side in the parameters box and hit search, and then you can zoom in and out on that, and you can put various other you can overlay a number of different things. You can see where the spectroscopic objects are, where there's photometric data, where we've measured magnitudes, and then obviously the various surveys below that. And you can mark those on the image. You can zoom in and out. You can see the boundaries of these what has made the Sky Survey so productive is the ability to not just capture one spectra at a time, but to capture at first 600 and now 1,000 spectra at a time, and multiple plates, multiple runs per night. So we're able to, that's what has made this survey so incredibly productive. So while you're...
Productive night took spectra of 10,000 galaxies in one night, which is pretty amazing. 10,000 in one night, yeah.
Can you show the plug plate? Because these are the coolest things ever.
The plug plate it's a really neat scientific artifact.
I've been wanting one forever!
Well, you might be talking to the right people.
I've been bugging my friends from UVA, but I keep moving, so I need to stay still first.
Yeah, so these are, these are large aluminium plates. These have physical holes drilled in them, and those colorful wires that you see are the fiber optics. So each of those holes is drilled very precisely to match the position on the sky of an astronomical object that we want to take a spectra for. And then those fiber optics are plugged by hand. People here are better than any machine that has ever been investigated for use for this. So they're plugged by hand by our fiber optic technicians at Apache Point Observatory. And then this aluminum plate is bent at the focal plane of the telescope. So that little cart thing you see in the picture with the telescope in the background is sort of rolled under the telescope, bolted in place, and then the whole thing has to be bent to match the optics of the telescope. It's actually a really amazing thing. And that lets us take spectra of up to 1,000 galaxies at a time. Or in Mango, which is the new survey I'm super excited about, we're bundling those fibers together so we take 130 up to 130 spectra of a single galaxy at a time.
Wow.
Kind of fun.
So cool. Sorry, I had to squee at the plate.
Those are beautiful. Oh, wow.
So one of the other things that we're doing, the web chat number 4 has the Explore tool on it, and that you can go to. So if you're messing around in the Navigate tool and you find something that you really want to see all the data for, you can then, there's a button on the side, and you go to Explore. And this is the same data that the scientists are using. In fact, the scientists use this, but what the job of the EPO has been is to get students into this data and make it possible for them to use it effectively to do things either with their classroom or independent research. And interestingly enough, we've had part of what came out of this was we have the citizen scientists are so enthusiastic that they were actually drilling into these tools and figuring out how to use them. So we went and wrote, normal people friendly help instructions for these, which we have living on Voyages now.
So tell us a little bit how Voyages, the SDSS Voyages got started. Because the Sloan Digital Sky Survey was one thing, and it's had many lifetimes of surveys now. And then where does SDSS Voyages come in? So this is voyages.sdss.org. It's over in the Showcase app. If you open that up, if you're watching this live, and I'll put the link in the Google Plus page as well. So tell us a little bit about where that came around.
Okay, well, and that's, if you want to show a screenshot of it, it is on number 1 on the ones I sent you. What we did was originally, I think over 10 years ago, when the web wasn't nearly as sophisticated as it is, and before the next generation science standards came out, we had lessons on Sky Server itself under the education page where you could access. They're mostly, lab type activities that would take you through concepts in science, in astrophysics at different levels. So, but they were mostly straightforward cookbook, and partly because that's just where the technology was at the time, and they were very good and they were well used, and we had good data on which ones were being used. But what we wanted to do was take advantage of what teachers had started doing with the data themselves and trying to get students into unique pieces of the database. So if you've got this like 230 million object database, you don't really need everyone to be using the same data. So Voyages grew out of focus groups of experienced Sky Server teachers who said, well, okay, this is what we'd really like to see happen, and here's our dream vision for what we want. And so some of the big things that we were responding to were diverse classrooms, the need to have things accessible for highly motivated students, as well as students who were either struggling in reading or English was a second language, or just a number of different reasons that we wanted to do that. Also needed to have things chunked so that we could go in and instead of having to commit 2 weeks to doing one of the activities on Sloan, that you could go in and do 1 or 2 days. And there needed to be a lot of backup. And there needed to be more support that wasn't necessarily reading based. So what we did was we surveyed the teachers, which one do you want to see us rewrite first? And that's where we started. We started rewriting and just pilot testing what we did. And we came up with a plan by which Voyages is divided into sections. And there is pre-flight, launch, and expeditions. So pre-flight is your skill-based, it's reading. If it's text or a concept, whether it's the telescope itself, that's in pre-flight. And it's just basically your skill-based activity. You can use it as a homework assignment, or whatever, or pre-reading, or whatever you'd like to use. Or you can use it for backup. If I'm stuck, oh, I forgot what this meant, or what was it, I can't remember where the Sloan filters fall, then you go ahead and you have that as your backup information. Great, thanks a lot for showing that. And then, One of the things that we tried to add in pre-flight too is now the next generation science standards are really emphasizing engineering. We heard a lot from teachers that this was going to be an area of struggle. So we wanted to rewrite a lot of the language in here to emphasize the idea that we have engineering thinking and scientific thinking and emphasizing the language of engineering. So we put in capped the SDSS telescope and the instruments and accenting the types of data. We really put in, these are just pre-flight. This is informational. Talks about the difference between spectroscopic and photometric data. What is that? And gets students just to think about how data is different and how data solves a problem. If you need to answer a question, you need to ask the question, what kind of data do I need to answer the question? So that's where pre-flight is. Launch activities are activities that are require 2 to 3 different class periods, and they get you into a different area of the database to discover. So the process of learning science is or doing science is that you observe, you observe patterns, you observe, and then you come up with very few theories from a lot of observations, from a lot of dealing with the data and trying to define the data. And that's what we wanted to reflect in. We wanted to reflect the practices of science in the launch activities. So we give you a launch activity that instead of telling you what color in astronomy is and how we measure it, and then having you go do an activity that has you confirm that I was right and that I'm really smart, instead, I just send you out to a unique area of the database on your own, have you gather some information, look for some patterns yourself, and then come to you're led into, you're asking questions about color. But I don't tell you anything about magnitude coming into a color activity. I try to tell you as little as possible. So these activities get a bit messy. They take a little bit longer. I have put in a lot of video help support for, okay, you're reading along, you're stuck, you need a little shove. What I'd love to have is like this artificial intelligence that just sort of intervenes at the point when you get stuck and just tells you just that little piece that gives you a shove into the next idea. But in lieu of that, we have a lot of video clips that help the students do that. So launch activities, what you want to remember when you're doing a launch activity is that every student has the opportunity to go to a unique area of the database, deal with their own data, or they can do it in pairs or however you want to do it in your classroom, but no one's looking at the same set of data. They own a little piece of the sky, and then they go and gather data from that area, and that's where they're drawing their conclusions from. It also makes it so it doesn't guarantee that everyone's going to get nice, neat results. And so you rely on your classroom to pool their results in order to look at the pattern. So an individual or group can look for a pattern, and then you can pool that as a class. So, and also with the launch activities, I wanted to structure it in such a way that it's always reminding students that there's a structure to the universe. So we know that developing a mental model of the universe is one of the key things that we want students to get out of their encounters with the next generation science standards. So we have them chunked into launch to the SDSS. So that's what's the database itself. So that's the engineering piece of it. What is SkyServer? What's a database? How do I find a spot in it? And launch to the solar system is definitely under construction because Sloan was not designed engineering-wise to look at solar system objects. So we have some asteroid activities, but I am so opposed to having everyone do a cookbook, everyone do the same thing, that this area is an area that is a bit of a struggle yet. When we get into the Milky Way and to the cosmos, so in the Milky Way we're looking at objects that are within our within our galaxy. And then when you go to launch to cosmos, you're encountering concepts that have to do outside of our galaxy. And my cat has decided that attention. So The dog, the bird, the tortoise, and the snake are all happily out of the room. But
one of them got through. We had a little zoo going on during our practice hangout for while we're giggling.
Oh, so the last section in Voyages is the long stuff. It is we call it an expedition. In an expedition, you really are required to know something going in. You better have some tools in your belt. These are the 2 to 3 week explorations. And right now, the one that's best developed is the expedition to Expanding Universe, which is a historical walkthrough of how did we come up with this idea that the universe is expanding. So if you can go over to expeditions and show them that expedition, yep, just go to the home page and click there. That landing page, I made this activity so that you could, as a teacher, go through this and say, well, I'm going to have all of my students go through step 1, step 2, and step 3. So in order to decide that our universe is expanding, we had to first know that there were other galaxies. Well, how did we do that? And the galaxies are really, really far away. Well, how do we get this distance idea in there? And then finally we made it to the redshift distance relationship. And so I try not to give much away, but also make it so if you were doing this with a class, you could stop. You could have some students end up stopping after step 2, or you could have them stop. There's multiple stopping points where things come to a closure, and students are able to get the skills that they need into their tool bag. But I'm trying to provide a lot of flexibility. And but they're still having to gather data, draw some conclusions before they can kind of successfully go on. But if you are a lab teacher at the college level, and you've got, we have already really gone over that, there's more to the universe than the Milky Way, well, let's just jump in at step 2. So I've tried to set all this up so it's really flexible. And that's basically it. In the help section, I'm waiting to have a programmer drop from the sky and redo my widgets on that, but right now they're as friendly as we can get them. And so we've tried to put in a lot of helpful student-level information on the help sections on how to use the tools. So if you're looking for lots of questioning in Voyages about what tool would you use, what kind of data do you need, what evidence do you already have to support this idea. So you have to keep going back and looking at what other data do I need, how do I find it within Sky Server. And so hopefully all the help is put in student-friendly language, but also remind students as I'm showing them a tool, why would a scientist choose to use this tool? So I try and embed that in there so they're learning about not just blah, here's a piece of data, but what...
Great. Go for it. Go with it.
Nicole, I'm just assuming that since your listeners are voting on a tattoo that my cat really isn't. No, that's not a problem. Okay, so that's my pedagogical pitch on Voyages.
That's great. It's so well constructed, and you've got so many resources in there. Are teachers finding that their students are kind of taking this on their own, even maybe working on it at home or doing their own interacting with it, independently, or is it
very little
in the classroom?
I'm getting very little of that so far, although I've had a lot in the past of independent work, especially when it was the old Voyages. But because this is so, it is tricky. I have not had teachers in yet that were not experienced in astronomy. And ultimately, that's what I'd like to be able to support, is I do not have very robust teacher help materials yet. Somebody who is really a newbie in astronomy would truly struggle with this, and I just could not. I'm really working on how do you satisfy the need for more teacher support without providing this cookbook. And because all the data is different, no student comes up with the same answer for an activity. I cannot write yet here's the answer to your journal. I have provided PDF journals for students to fill in if the teacher would like. A lot of teachers really wanted that, and I would love to see that change to an online journal. That's in my future. But I can't give you an answer key for most of that because it's not all the same.
Yeah, you have to really have teachers that are comfortable with that, and that's a big shift for a lot of teachers, and hopefully not all of them, but for still quite a few, it's a whole different way of doing things.
Isn't as familiar for a lot of teachers.
Right? Yeah, I mean, it's one of, for me, it's one of those real strengths, though, that this is a tool that you can use to teach the real scientific method. You know, teaching children, young people, that there's not always a right answer in science, I think is incredibly valuable.
Yeah.
It's something that, you know, also my experience with working with citizen science in the classroom, you know, there's no right answer there either. There's no right answer to some of the questions that are being asked. But teaching young people to keep trying and to do their best and to work at it, I think is a really valuable life lesson as well as a science lesson. So I hope
and mathematically,
but ultimately it's the right philosophy.
And mathematically speaking, when students are into, say, the expedition to the expanding universe, and they're taking a sample of the distribution of galaxies versus stars across a particular deck in the survey, well, they may not see a pattern in that with theirs, but once they pool it with the rest of their classmates, a pattern may emerge. Mm-hmm. So this statistical, this really juicy mathematical lesson about what happens when you get sufficient quantities of data is just super cool.
Like, that's one of the biggest strengths of SDSS, is it's just massive amounts of measurements, and these population studies that can be done based on that is really huge. Can I ask you about these little stars you have next to the activities, because that will help people, I think, decide which ones are best for their classroom. I'm going to try and screen share this, but the text might be tiny, so you may want to walk through this.
Okay, very good. So one star, I also was trying to make this so it wasn't just USy. You know, I want to make that, you know, that we had to figure out a way to communicate that if, and also didn't want to limit this to say, oh, this is 1 star is for middle school.
Right.
That's not the idea. Are you new at this? How confident, you know, am I that you could anyone could be successful in doing this on a just run-in bait, you come in, you know, cold. And so 1 star activities are, in my mind, are the you know, the middle school early. This is their first encounter with big data. Anybody should be able to do this, but this could be a very successful activity with any age level. I did not, you know, that. In fact, that is sometimes a weakness, that language. I would love to have a lower level reading level on some of the activities, but not my area of expertise. I need to go there at some point. So 2 stars, I was picturing your high school physics or astronomy class where you had more time to spend, and you also had a little bit more math in your toolkit. And 3 stars means it's going to require some perseverance, some sophisticated science thinking, and students are able to, you know, move forward independently. This doesn't have to be seriously guided. So, or if you're going to do a 3-star activity with a diverse audience that you know you have warning, you better have some backup plans for. You better have looked at what the pre-flight supports are. You know where there's help available, so that when people get stuck, you can shove them in the right direction.
So, purely selfish question, since I will be teaching a college astronomy course in the fall, do you recommend this? I mean, for intro astronomy, have you seen particular feedback from college students using this?
Yeah, and I've seen, okay, so the basic, your 101 astronomy group is your very diverse audience. Some people who may be, you know, science phobic, but astronomy sounded cool, or it sounded easy. And then you've got people who really have, you know, are just taking this as their first of many courses. So yes, I think that it is there, and I would always start with the activity, my special place in the database. Mm-hmm. I am really convinced there's a PhD, you know, dissertation in here someplace. Mm-hmm. Because I have watched students when very science phobic, not enthused about what they're doing or have taken my astronomy class because they thought it would be easy, get incredibly invested in learning all sorts of tough stuff because they have owned a piece of the sky that they found some wacky looking floccular galaxy in, and they found something that they seriously want to investigate. And so when you start off with that, my special place in the database, not only do you get a bearings on what is this thing called Sloan, we're not just diving into pretty pictures. There's a database and what that is. And so I would start there, have everyone take ownership of their piece of the sky, and then from there branch out. And any time that you're doing, whether it's filters or color magnitude, you do your hands-on activities, you do all those cool things, but then you go and look for it in the, you look for the data that will back that up. If you click on that star wheel there, this was the toughest thing for me to do, was to come up with a way for you to know where Sloan had been. And so all the brightest stars in the constellations that are part of the SDS database are marked on here, and they're live links into the Navigator tool. So if you go in there and click on them,
no, it's always gonna not work, wasn't it?
It worked yesterday. I checked. I truly did.
I clicked the wrong one, maybe.
No, I feel one's broken, the others are broken too. So I've got. We will fix this immediately, but you go and it will take you where you want to go in the database, so that you don't, at this point, you don't have to understand RA and DEC. You don't have to understand location in the sky. All you have to know is I understand constellations. I understand that there's stars up there and they're organized, and then you start getting this sense of what is out there. Oh, there's a location for that. How did the database find that? And you build from there, instead of starting like when I was early in astronomy. Okay, we're going to talk about the location of the sky, and then we're going to talk. We had this sequence. Now just dive into the middle of the fun stuff, and then branch back into getting the basics.
So I want to say two things, Kate. Can I say two things?
Oh, I'll shut up long enough. Yeah.
The first thing is, if anyone's exploring this website and finds a little gremlin like that, they can let us know. outreach@sdss.org is a good email to let us know about the gremlins, and we will get them fixed as soon as we possibly can. And the second thing is that the way that we've designed this website is to make it something that we can continue to add to. So if we want to add additional activities. I'm particularly excited about the advice for teachers in different scenarios for how to actually use this. So one thing that we might work on adding is an advice for Astro 101 lecturers about how you might use Voyages. There's a few examples of those sort of case studies of how teachers might use them in different scenarios. Kate mentioned using this as a tool for teaching about engineering, and actually, the importance that engineering has on astronomy. But there's a lot of different ways that Voyages could be put into different types of curriculum. You might have noticed I'm not American, and neither do I live in America. And we, here in the UK, we have our own national curriculum and our own set of science standards. And we, Voyages can be used to support that as well. And we're going to be developing some advice for how to fit it into the UK national curriculum at different levels. And the Sloan is a massive international collaboration. It's becoming more and more international. It started very US-focused, but now half of our collaboration are outside the US. We have Chinese members, Spanish, down in Chile. We're actually moving to the Southern Hemisphere for the first time with instrumentation at Las Campanas Observatory in Chile. And so that, we very much want to make Voyages something that is going to sort of spread out internationally. But yeah, we started with, Kate's really fantastic advice about the US, how to fit this into the US standards, which is really, really important also. So.
Well, it sounds like you could have a lot of really cool international classroom collaborations too, or at least some discussions among students from different countries about what they're studying and what kind of investigations they're doing and what kinds of things they're learning as it becomes, sort of global, worldwide.
Yeah. So translation's always a fun challenge, but we're currently working on the Chinese and Spanish translations of a lot of the websites.
Fantastic.
Voyages will go into that pool for working on the translations. We have access to all these amazing scientists who are bilingual or at least very fluent in their own language and English typically. So that's a fantastic resource as well.
Mm-hmm.
So we did at least take we made an introduction video, which was just me doing low-tech stuff, and I'd love to see that develop in the next generation and be something that is slicker and cooler. But the idea was that if you're going to jump into this and you don't want to go into what is the database and what is the telescope, that you can show a 3-minute video and get the basics across, because I don't think you should just dive into this without ever having mentioned where this information is coming from. So that we did manage to get translated into Spanish, so we have that one. And
sign language, which was really, really neat too.
What's that?
And it was translated into American Sign Language also, Kate, right?
Yeah, yeah.
Yeah.
And I do need to add a voiceover for that one because it's not as accessible as I'd like it to be for the diversity of the deaf and hard of hearing community, but those are on the homepage, and there's a video about plate plugging and SDSS going, how that telescope gets set up at night, and so those are all on the homepage for you to take a look at, and those are all really kind of fun videos that have been made by people in the collaboration. So as things get developed, we will put them here. They have a home.
What I like about that navigation activity is very few activities tie in, because you can take your students out and do the constellations and look through, backyard telescopes, and that rarely ever ties into the astrophysics that you teach in the classroom. And this is so cool that you're tying directly, like, that star you saw last night out in our lab is actually part of this data set. So I love seeing connections like that, because they can look up in the sky and it clicks that data set is coming from right above their heads.
Right.
I can see them. Are a big nightmare for the scientists, but they look pretty impressive in the imaging. So I've seen lots of kids be like, "Ooh!" and to me, it's horrible. You get these massive diffraction spikes from the optics. They're just way too bright, overexposed. They mess up everything anywhere near them, but they do look really cool. So. Yeah,
and it gets across that sense of how, without having to go through the mathematics of how much that telescope is magnifying the image, you can very quickly get the idea that, oh, I saw this with my eye and it looked like this. And when we go to the database, it completely oversaturates the entire field of view. And what does that mean when that happens? What's going on here? And you got into magnification.
That we have all these videos on the SDSS YouTube channel also, and one of my favorite ones is a zoom out from the Whirlpool galaxy, and it zooms out and it shows the entirety of the SDSS imaging as on like a globe, so you can see the full scale of the imaging. But I just love that you can come from this really familiar galaxy. That would be a good tattoo. Whirlpool galaxy, that's insane. In my view.
Infrared, like did in grad school.
Sure, have it in infrared. But it's cool in the Sloan imaging too, and then just that zoom out to really emphasize the scale of the database is really neat.
Very cool. Very cool.
All right.
Let's see. Are there any other particular features that you want to point out to the site? Maybe some places. Where would you recommend someone completely new to this get started?
A teacher, I would start with go ahead and do the ground control, which is what teacher materials I have. If you're a teacher, go there. If you want to play, I would just scan down a menu and find a topic that you think you know something about, and go in and see what happens when you play in the database.
Okay.
Any special technology requirements for interacting with this site, or basically internet and a computer?
And that is, when I did this, that was one of the challenges, was I wanted to stay away from having to use any outside resources. And since a programmer did not come with this project, and now those tools are being developed, but so we did all of pre-flight launch, and most of expeditions don't rely on anything outside, although I have taken advantage of the tools that were developed as part of Galaxy Zoo in a number of them. So there's Launch to Galaxy Shapes and the Expedition to Galaxy Color that use the tools of the Galaxy Zoo, so some of the display tools and the graphing tools that are online. And hopefully we'll develop some of those in-house related to the SDSS soon, and as soon as they do, I'm going through, and there's some major rewrites that'll happen so you can graphs popping up all over the place and that sort of thing.
Very cool. Do you have any what kind of feedback have you gotten from teachers or students using this?
Well, so far, really excited because most of the people who've been doing the pilot testing are people who helped with the focus groups and told me what they wanted. So I feel like the Astronomy Good Fairy, I just delivered what they really, really wanted. And when they find something that's not working, I've been, because I've gotten such support and flexibility from Karen and from Jordan Raddick and the folks at SDSS, I can just kind of stop what I'm doing and remake a video or make a different tool, make it work for them so that it's clear. So that's I've had really good feedback so far on a number of the launch activities and expedition, the big expedition that I have out. But we have not done any large-scale pilot testing on this yet. And that's part of why I'm holding off on developing more materials. I really want to see, especially with the expeditions, what kind of format when you're doing authentic research that's more open-ended and long-term, what really works well before I do a bunch more.
So what's next for Sloan? I feel like this juggernaut keeps going, and when they keep coming up with great new survey ideas. What's in the works now for Sloan?
So I mentioned a few of the things that are going on right now. There's a couple of really exciting developments in terms of taking the Apogee survey, which is the survey of stars in our own galaxy, is making a second instrument and taking it down to Chile, so it's going to be able to survey the galactic fold to galactic center, as well as keeping one in the northern hemisphere because we are surveying the Kepler field. Which is this field that the Kepler satellite's finding lots of extrasolar planets in. So that's really valuable follow-up to that. Then we have the Manga survey, which is getting really detailed spectra, and that's it's a ridiculously rich data set. You're going to see my bias here. This is the survey I'm most involved in. But we get, it's just an incredible amount of data. I can't even quite. We get something like 500 spectra for an individual galaxy, and we get 17 spectra per observation, 17 galaxies, per observation, and we do several of those. It's just a ridiculously rich data set, and it's going to, we're sort of in the phase of talking about how to modify Navigator, how to modify the data access tools to enable this you get basically a data cube. You'll be familiar with this, Nicole. We get a data cube, but instead of just one emission line, like in radio astronomy, you might have one emission line. You get hundreds of emission lines and absorption lines, and you can fit stellar models, and you can get stellar ages, and you can get all these maps of galaxies. So that's really exciting. And then the cosmological mapping is ongoing. We're going to more distant galaxies, so fuzzy blobs on the sky. No bias there at all from me. But it's really important cosmologically. It's filling in a gap between what has been done, Ross has been done so far, and what will be possible with sort of the next generation of surveys after this. So that's a really valuable thing to do too. So it's just ongoing.
I've never worked with Sloan data, my own research, since I stuck to radio, but Apogee holds a special place in my heart since it was built at University of Virginia while I was there. So yeah, I got to visit the clean room and do all that fun stuff while they were putting it together. I think they hooked it up to like one of our 8-inch telescopes to get first light. It's so ridiculous. So yeah, it's been really exciting just to watch that one small piece of that very large collaboration that all focuses around this telescope at Apache Point.
Yeah, it's an incredibly productive telescope. And so the current phase of Sloan, we're in Sloan 4, will run through 2020, and annual data releases will be continuing through that time scale. And then, it's a collaboration of hundreds of scientists with some really big ideas and some big ambitions in it. So let's see what happens after that. As in all science, it's a quest for funding, and so we'll have to see what the idea is to modify the telescope, or we'll see. It's a 20-year-old telescope now, so but it's still hanging in there and doing really good science. So.
That's also what's amazing. It's a 2.5 meter telescope. It's not a behemoth. It's not, it's a large telescope, but it's not, 8 meters, 10 meters, and yet the science that's come out of it is mind-blowing.
Well, you know, if you go too big with a telescope, your field of view gets very small. So actually, modest telescopes, if they're on the ground, you know, you're not benefiting from seeing by getting bigger. You know, you're not benefiting in resolution by getting bigger because you've still got your seeing. You get a bigger light bucket, obviously, so you can go fainter. But it works really, really well as a survey telescope for covering really big areas of sky. And I think that's, you know, that's really the niche that Sloan has put itself in. But yeah, it's the same size. I always think it's neat. It's the same size as the Hubble Space Telescope, roughly.
Really? Okay, yeah, that makes sense. Yeah. And so I know, Kate, you talked about a lot of things that are coming up next for the site for the Voyages project. Is there anything big or in particular that you want to focus on that's coming in the future?
I'm looking forward to they're doing some development at Johns Hopkins with more online tools so that students can log in and have their notebook, so when they're in Navigator they can make a collection, and we can export that collection to graphing tools. And that I'm really looking forward to having that available. It opens up a number of different activities that are closed to me now unless I have people use outside programs, and I'm pretty devoted to not having the need for outside programs because the lower high school and middle school level students, there's just not the time available to teach, you know, those things as part of the lesson. So I want that all to be easy. So that I'm really looking forward to, and I'm looking forward to getting more teachers into the site and getting more organized about how I receive feedback and what I do with it, and maybe holding some, I'd love to look for the money time. I would like to do it so we've got some people who are really interested in Voyages get together and we support a development sprint. I would like to get together during the summer, and then we all just take our favorite thing and write it, and then send it back to me, and I make it all uniform and get it on the web, and so that this from here develops organically from people who have the boots on the ground and really know their audience, and that's U.S., international. From here we can really branch out: deaf and hard of hearing, blind and visually impaired, the whole 9 yards.
Are there plans to have you done teacher professional development around this?
A few. So mostly in like the Chicago area, where I'm moving to be the education director at Yerkes Observatory on an interim basis here. So I will be moving in June, and so we'll have those are mostly where our teachers have come from, because we have been doing SDSS work with them for 12, 15 years.
But we should also say that there's a workshop happening near the University of Washington at the end of this month on this sort of theme as well, with teachers up there, working with Oliver Fraser, who works up at the University of Washington. And we're also planning to run some workshops in Hawaii this summer, tied into the AAU. We hope that'll work out. And what's the other one called, Kate? The Global Hands-On?
Yeah, we'll be doing a one-day workshop with the Global Hands-On Universe group in Hawaii on, I think it's August 8th.
And I just today chatted with our outreach officer here about how we could do this in Portsmouth. What would be the best way to run something in Portsmouth? So
the best way would be to fly me to Portsmouth. Best way.
Kate's been angling for a trip to the UK for so long.
I'm one of these typical Americans that hasn't been off the continent yet.
I was that for a long, long time. And then I went to the desert in the middle of South Africa, so I went, all out for my first trip.
You go to Hawaii, though.
Yeah, that counts, yeah.
That counts.
Sort of.
That's a really long way, but without the tiny violins, right? Poor Karen has to go to Hawaii. So.
Yeah, I know.
Anyway. I kind of have to go pick up my kids.
Oh, yes, that's right. Go on. Thank you so much for joining us.
Okay.
Yeah, bye, Karen. Thank you. Yeah.
Bye, Karen.
Bye.
Bye. And Kate, I'll ask if you have any last resources you want to plug for, or any last message for people who want to get into SDSS Voyages.
We'll get into, at some point, we are going to be doing a plate packets. So we are looking at the possibility of shipping out plates to educators with resource material that's tied in with Voyages. So that's kind of exciting on the horizon. But no, I think I have exhausted my mental state for the moment.
Well, you deserve a nice nap since you've been in meetings till late at night and and almost lost a piece of your thumb.
I did lose a piece of my thumb.
It's enough that it'll regenerate, right?
It's a little odd, but it's going to. Oh gosh.
Ooh.
I really am a good cook.
Well, thank you so much for joining us.
Very
Really
much.
glad I got to hear more about this. And yes, I may be bugging you myself as I start, as I launch into the next phase of my career and teach Astronomy 101, because I would like to incorporate some of these activities as well, since it looks much improved from when I did it in grad school. And it was like I had to learn a little bit of SQL first. You know, that way I can throw my students right into this and get them started.
And now you can do SQL with drop-down menus. So
I think they can handle that.
I still use it to get started, and then I tweak.
Yeah. Oh, that makes sense. That makes sense.
Your typing doesn't have to be so accurate. You just let it spit out the initial, and then you go change, edit.
Well, thank you so much. This episode will be available, continue to be available on YouTube, where we're broadcasting for later viewing. The audio version will be on 365 Days of Astronomy, so of course if you couldn't see the cool stuff for screen sharing, you want to check out the video. Go to voyages.sdss.org to check out all of these amazing tools, and I think your email was outreach@sdss.org to give you guys feedback.
You can reach us through the website as well, and make sure you sign up for. Eventually, I'll be getting little newsletters out, so I'll get alerts when I add something. Or you can send me alert when something's broken, which appears to be an issue that I need to. Okay.
Like when things break and you're like, oh no, we're on air. And I'll remind our listeners to check out the Google event page for a Google Doc form link. If you have suggestions for the Hangout-a-thon tattoo, please send me suggestions for my next astronomically themed tattoo. Don't tell my mother. I'm 30 and she'll still be.
Can't wait to see. Yeah.
It'll be fun. I don't know. I was hoping to get it done before I moved at the end of June, but financially that may not occur. So this may happen after I move. But it's the internet. You guys will all see it. So.
Yeah. No problem.
All right. And so thank you guys for watching. Again, thank you for all your support. Make sure you check out our website. I've got the URL under here. It's cosmoquest.org/x, well, blah, 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 blah. Learningspace. Just go to Google Learning Space. It'll take you to our link on the CosmoQuest website. We have a Patreon campaign going as well. So thank you guys for watching. And we'll see you in 2 weeks. We will have Pat and John. John Feldmeyer and Pat Durrell will be on the next show on May 20th. I'll be picking their brain on Astronomy 101 topics and cool classroom activities.
Other fun stuff. Yeah.
Yeah, like I said, another partly selfish episode because I'm excited about teaching astronomy again.
That's okay. That's okay. Then after you've been in the classroom for a while, we'll just turn tables and pick your brains about what's going on in your world. So.
Awesome.
Enough stuff there.
All right. Well, thank you guys for watching, and we'll see you guys in 2 weeks.
Thank you.
All right. Bye, everybody.
Bye.